Most of the hydrocarbon in petroleum and natural gas belong to the family of compounds called alkanes. Petroleum contains alkanes with up to 70 carbon atoms, and natural gas is mainly methane with small amounts of ethane, propane, butane, and other compounds. Propane and butane gas are used as liquefied petroleum gas inside gas cylinder, which used as household cooking fuel. And vehicle fuel, such as petrol and diesel, mainly contain octane. The learning outcome, we need to state 1. What is alkane? And what is structural formula? Deduce the molecular formula and draw the structural formula for the first 10 alkane. Deduce the general formula of alkane and name the first 10 alkanes. Next, we will learn about alkane physical properties and how the physical property changes with increase in the number of carbon atoms per molecule in alkane, and explain the effect of the increase in the number of carbon atom to the boiling points of the molecules. We will learn two chemical properties of alkane, which is complete and incomplete combustion, and also substitution reaction. And we need to write the chemical equation for both combustion and substitution. And last but not least, how methanes affect everyday life. Hydrocarbon belong to the family of compound called alkane, have name ending with A and E. The molecules within alkane family contain carbon and hydrogen atoms only, so they are called hydrocarbon, and each of the carbon atoms covalently bonded to 4 other atoms by single bond only, so they are said to be saturated. All the members of a family of compound or homologous series can be represented by a general formula. In the case of alkane, the general formula is CnH2n plus 2, where N is the number of carbon atoms present, which is 1, 2, 3, and so on. Naming the alkanes. All the alkanes have name ending in A and E, while the root name tells you the number of carbon atoms present in the molecule. For example, the compound name will begin with meth, METH, if it has 1 carbon atom, eth, ETH, if it has 2 carbon atoms, prop, PROP, if it has 3 carbon atoms, and but, BUT, if it has 4 carbon atoms. Starting from 5 carbon atoms to 10 carbon atoms, the root name is very similar to polygon. For example, pentagon, pen for 5, hexagon, hex for 6, heptagon, hept for 7, octagon, oct for 8, nonagon, non for 9, and decagon, dec for 10. So by combining the root name, which refer to the longest carbon change, and the ending name, which is A and E, we will get the name of the alkane. So let's do one example. Alkane with 3 carbon atoms. 3 carbon atoms, the root name is prop, and ending with A and E. So prop plus N, we get propane. This table summarizes the name and the molecular formula for the first 10 members of alkane. The molecular formula shows the actual number of atoms of each element that are present in a molecule. The molecular formula does not show how the atoms in the molecule are bonded to each other. 1 carbon atom, root name is meth, and the ending is N, so methane. 2 carbon atoms, the root name is eth, so the name is ethane. 3 carbon atom, prop, so the name is propane. 4 carbon atom, the root name but, so the name is butane. And from 5 carbon atoms to 10 carbon atoms onwards is pentane, hexane, heptane, octane, nonane, and decane. We can deduce the molecular formula of alkane by using the general formula CnH2n plus 2, where n is the number of carbon atoms. So when n is 1, Cn, C1, H2n plus 2, 2 times 1 plus 2 is C, 2 times 1, 2 plus 2 is 4. So CH4. When n is 2, C2, H2n, 2 times 2 plus 2. So C2, H2 times 2, 4 plus 2, 6. H6, C2H6. When n equals 3, Cn is C3, H2n plus 2 is H, 2 times 3 plus 2. C3, 2 times 3 is 6 plus 2 is 8, so C3H8. And the same way to deduce the molecular formula of the rest of the members. Next, we will discuss the structural formula of alkane. Structural formulas show how atoms in a molecule are bonded together and by what types of bonds. So I will illustrate how to draw the structural formula of methane and ethane. So first, we will start by drawing the carbon atom. So methane have 1 carbon and ethane have 2 carbon atoms. Since carbon can form maximum of 4 covalent bonds, we will write 4 bonds around each carbon atoms. 1, 2, 3, 4, and also 1, 2, 3, and 4. 1, 2, 3, and 4. And each of the vacant bond will be bonded to hydrogen atom. So we will write hydrogen on each of the bond. Last step, we will count the number of hydrogen on each molecule to see whether it matches the molecular formula. 1, 2, 3, 4. So 4 hydrogen matches the formula CH4. 1, 2, 3, 4, 5, 6. So matches the molecular formula of ethane C2H6. So when drawing the structural formula, we don't have to keep counting how many hydrogen are we drawing. As long as we are writing 4 bonds around each carbon, the hydrogen number will tally. So let's do one more example, butane C4H10. So again, first we will start by writing how many carbon atoms in the molecule. So 4 carbon atoms, 1, 2, 3, 4. And around each carbon atom, we write maximum 4 bonds. 1, 2, 3, 4. 1, 2, so 3, 4. 1, 2, 3, 4. 1, so 2, 3, 4. And each of the vacant bond will be bonded to hydrogen. So we will draw hydrogen around the vacant bond. So now let's count how many hydrogen in the structural formula. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which matches the molecular formula of butane, C4H10. So again, we don't have to count how many hydrogen we are writing, but as long as we are writing maximum for around each carbon, we will definitely get correct number of hydrogen that matches the molecular formula. So we can see here the structural formula for the first 7 alkane, which is methane, ethane, propane, butane, pentane, hexane, and heptane. And the same way, we can draw the structural formula of any alkane. Next, we will discuss the physical properties of alkane. So I will start with physical states at room temperature. The first 4 alkanes, methane, ethane, propane, and butane, are gases at room temperature. The next 12 alkane from C5 until C17 are liquids, while the rest from C18 onwards are solid. So first, alkane have low melting point and boiling point because the molecules are held together by weak intermolecular force. However, the melting point and boiling point increase as number of carbon atom for molecules increase. This is because as the size of molecule increase, the intermolecular forces also become stronger. So more heat energy is needed to overcome the force. Next, alkane cannot conduct electricity because alkane, as covalent compound that consists of molecules, it have no free moving ions to carry electrical charges. Alkane is also less dense than water, which means alkane will float on top of water. But the density of alkane increases with increasing number of carbon atoms. And last, alkane can dissolve in organic solvents based on the like dissolve like principle, and so alkane is insoluble in water. Next, we will discuss the chemical properties of alkanes. Alkanes are saturated hydrocarbon with strong carbon-carbon and carbon-hydrogen bonds. The carbon-carbon and carbon-hydrogen bond must be broken for alkanes to react because this bond needed a lot of energy to break. Alkanes is generally unreactive. Under normal condition, alkane do not react with acids, alkalis, oxidizing agent, or reducing agent. We will discuss 2 main reactions of alkane, which is combustion and halogenation. Combustion of alkane. Alkanes readily undergo combustion when ignited. In the presence of excess oxygen, complete combustion of alkane occurs to form carbon dioxide and water. However, if there is insufficient oxygen available, incomplete combustion of alkane occurs, forming carbon monoxide or carbon with water. The equation shown here is the complete and incomplete combustion of methane. We will work on another example for complete combustion of ethane and propane. So ethane is CN, C2, H2N plus 2 is 2 times 2 plus 2 is 6. So C2H6 for ethane, and propane is C3, H2N 2 times 3 plus 2 is 8, C3H8. And burn in oxygen. And complete combustion will produce carbon dioxide and water. Next, we will balance this equation. First, we will start with the number of carbon atom. C2, so 2 carbon in the reactant, So we put coefficient 2 in front of carbon dioxide. C3, 3 carbon atom, so we put 3 in front of carbon dioxide. Next, we will balance the number of hydrogen. C2H6, there are 6 hydrogen, so we put 3 in front of water. C3H8, 8 hydrogen, so we will put coefficient 4 in front of H2O. Now, the tricky part is balancing the number of oxygen. So first, we will count the number of oxygen in the product. 2 times 2 is 4, plus 3 is 7. So there are 7 oxygen in the product. Only for combustion of organic compound, we can write fraction to balance the oxygen molecule. We will write 7/2 oxygen in the reactant. And for propane, 3 times 2 is 6 oxygen, plus 4 is 10. So that is 5 coefficient in front of oxygen. Even if we leave the equation as it is still correct. But if you want to get rid of the fraction in front of oxygen, we can multiply all the equation by 2. So we will get 2C2H6 plus 7 oxygen, 4 CO2, and 3 times 2, 6 water. Next, we will discuss halogenation of alkane. In halogenation of alkane, alkane will react with halogen in the presence of ultraviolet light to form haloalkane. This is a substitution reaction where one atom or group of atoms is replaced by another atom or group of atoms. The hydrogen atom is replaced by the halogen atom. So that is why this is called substitution reaction. Hydrogen is substituted by halogen. And in order to do that, carbon-hydrogen bond will be broken and carbon-hydrogen bond will be formed. So we will discuss one example, which is chlorination of methane. UV light is needed to break Cl-Cl bond. So this is a photochemical reaction, whereby this reaction will only occur in the presence of light and will not occur in the dark. If enough chlorine are present, all 4 hydrogen atoms in methane will be replaced. And varying amount of 4 different products are formed, whereby if 1 hydrogen is replaced by chlorine, it will form chloromethane. If 2 hydrogen are replaced by 2 chlorine, it will form dichloromethane. And if 3 hydrogen are replaced by chlorine, it will form trichloromethane. And if all 4 hydrogens are all replaced by chlorine, so we'll have 4 chlorine, it will be tetrachloromethane. So di is 2, tri is 3, and tetra is 4. The hydrogen that was replaced will combine with the Cl to form HCl, or hydrogen chloride gas. So next, I will illustrate the structural formula for the first substitution of hydrogen by chlorine. So CH4 react with chlorine Cl2. One of the hydrogen will be replaced. And 1 hydrogen replaced. 1 chlorine replace the hydrogen, and the hydrogen that was replaced will combine with another chlorine atom. So 1 hydrogen can be replaced to form chloromethane, 2 hydrogen replaced to form dichloromethane, 3 hydrogen replaced to form trichloromethane, and if all 4 hydrogen replaced, it will form tetrachloromethane. And you can draw the structural formula the same way here. That's all for our lecture today. Thank you.